All right, today we're doing 10.4, which is using the Pythagorean theorem. So basically it's just taking what we did yesterday and using it in a little bit different way. We're going to be using the converse actually. So remember, the Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. The converse of that is where you flip the beginning and the end. So now if a squared plus b squared equals c squared, then you have a right triangle. And that might seem obvious, but converses are not always true. So for example, if I were to say, if it's raining, then the sidewalk is wet. Well, of course, if it's raining, the sidewalk's wet. But if I say, if the sidewalk is wet, then it's raining, that's the converse. It's where I flip-flop the beginning and the end, or the if and the then. That's not necessarily true. If the sidewalk is wet, it doesn't have to be raining. It could be a sprinkler, or somebody could have spilled a drink. So the converse isn't always true. However, in the case of the Pythagorean theorem, it is. So if a squared plus b squared equals c squared, then you have a right triangle. So what we can do is you can be given a couple of numbers, or a couple of side lengths of triangles, and you have to determine if that triangle is a right triangle or not. So for example, if I gave you these three sides and I said, is this a right triangle? What you would do is you would first of all find the longest side. In this case, that's the 18 centimeters. Remember, the longest side, if it's a right triangle, is your hypotenuse. So that would have to be associated with C. And then the other two sides, or the legs, could be, A and B or B and A. It doesn't matter. So what I'll do is I'll put these into my equation and I'll see if it works. So the Pythagorean theorem is a squared plus b squared equals c squared. Substitute what I have. And then 15 squared is 225. I don't have to do a calculator for that one. 10 squared is 100. 18 squared, I can't remember off the top of my head. Oops. Made a mistake. Let's see. 18 squared is 324. So I can see that 225 and 100 is 325. That does not equal 324. So what that tells me is this is not a right triangle. Now, if I had, let's do one more example. 50 yards, 40 yards, and 30 yards. And I want to know, is this a right triangle? I would do the exact same thing. Look for your longest side, which is my 50 yards. That's going to be C. And then A and B are the other two. So 40 squared plus 30 squared. Does that equal 50 squared? 40 squared is 1,600. 30 squared is 900, 50 squared is 2,500. 16 and 9 make 25, so this is 2,500. Lo and behold, that does equal 2,500. So this is a right triangle. The other thing that you can do with the Pythagorean theorem is you can also come up with what's called the distance formula. So in your book on page 327, they have all of the steps for how you actually can derive the distance formula. I really want you to look that over and try it. It's activity 3. I'm just going to give you the formula now, though, and it's in your book. So the distance formula says this. If you have 2 points, x1, y1, that's one of your points, and x2, y2. The distance between those points is the square root of y2 minus y1, or the difference in your y's, squared, plus the difference in your x's, squared. If you think about this, if we square both sides, we would have d squared equals the difference in your y squared plus the difference in your x's squared. So you can kind of see where the Pythagorean theorem is coming from. Looks like over here we have, oops, I didn't mean to put it out there. This is x1, y1, this is x2, y2, and I make a right triangle. I guess I do want that dot. the length of this side is, I'm sorry, it should be y1 minus y2. That's how long that side is. It's the difference in your y's. So just with that knowledge, maybe you can see how this works. Remember, when you're subtracting, if you switch, all that happens is you end up getting like the negative. So if I do 5 minus 1, I get 4. If I switch it and do 1 minus 5, I get negative 4. But when you square it, in both cases, I would get positive 16, right? So it doesn't matter if you do y2 minus y1 or y1 minus y2, because that squaring takes care of the potential negative that would be there. So just something to keep in mind. This is how it's always written. Using the distance formula, again, is super easy. You just take your 2 points. So let me come up with 2 random points. 1, -5, and 7, 4. So if I have those 2 points and I want to find the distance between them, distance equals the square root of, this is x1, y1, x2, y2. Difference in my y's, so 4 minus -5. Square that. The difference in my x's, so 7 minus 1. Square that, and then take the square root of it all. It's going to be equal to the square root of 9 squared plus 6 squared. So this will be the square root of 81 plus 36. 81 and 36 is 8, 9, 10, 11. Did I do something wrong? This one. Oh, I think I'm good. 81 and 36 makes 117. And 117, oops, I'm sorry, I went off the bottom of the page. So square root of 117, turns out 117 is divisible by 9. You might not have noticed that and finished right there, but this is actually 9 times 13. So this will simplify to 3 root 13. So if I'm doing a problem like this, 3 root 13 is a totally acceptable answer. If I'm doing a problem where I'm talking about like how far apart 2 things are, then 3 root 13 is a pretty horrible answer. Like if we're talking about 2 ships in the night, I don't know. So then I would actually do 3 times the square root of 13, and I would get about 10.8. So about 10.8 units in this case. So that's how you use the distance formula. I would write this down. Every homework problem that you do that uses the distance formula, write it down with the variables first, just to make sure that you really get that stuck in your head. I don't think it's too hard to use, you just have to remember it. There is a real-life application in your book where you just have to find the distances on a coordinate plane and then use those to help you determine if you have a right triangle or not. So it's putting this together with what we did up here. If you have a question on that, of course, you can always just stop and ask me, because I won't go through that right now. So hopefully this whole video worked, because I just did it in one take. So your homework is on page 530, and you are going to do numbers 1 through 4, 6 through 20 even, 22 through 26, and last but certainly not least, 27 through 30. So hop to that. This is the last section of this chapter, so you just have review and then you'll have a test. Make sure you're checking in with me if you have any questions. Otherwise, you can rock and roll on this assignment. So good luck.